Welcome to Structural Engineering Online. We are dedicated to provide teaching and learning support through video lectures. Please subscribe to our channel if you have not yet subscribed. Thank you very much. In this lecture, we will learn how to identify the zero force members in a truss. You know that truss is a structure in which all the members are connected by pin joints, and because the load is applied only at the joints in the truss does not have any bending moment. Our job will be to calculate the forces in the truss members, and we will find these two rules very helpful, that without any calculation you will be able to identify that some members are carrying only zero force. So your job will be very much reduced. So we will learn now these two rules which will help us in identifying which members are carrying zero force. So first rule is for two members and second rule will be for three members at a joint. So the first rule says if there are only two members at a joint, just two members, there should not be any support reaction at that joint and there should not be any external force at the joint, and these two members should not be collinear, means they should not be in a straight line. So how it will be happening, we can say if it is like this, one member here and another member here, these are two members, and suppose the force in this member will be F1, force in this member is equal to F2, and there is an angle theta between them. I will explain why these two members will have zero force, right? As we are saying that these two members will have zero force, but why these two members will have zero force? There is simple explanation. If I take this axis as x-axis and the axis perpendicular to this as y-axis, and if I resolve this force F2 into two components, I will get F2 cos theta, and this will be in y direction F2 sin theta. Now if you see here in y direction there is only F2 sin theta, there is no other force. So to maintain the equilibrium of the joint, because it says that sigma Fy equal to 0, that means algebraic sum of all the forces in y direction should be equal to 0. Therefore we can say that F2 sin theta will be equal to 0. If F2 sin theta is equal to 0, that means F2 is equal to 0, because sin theta is not 0, the angle has some value, it is other than 0. So once F2 is 0, we can apply in the similar way the equilibrium in x direction, and in the x direction we have F1 plus F2 cos theta is equal to 0, but we have got F2 equal to 0, therefore F1 is also equal to 0. So this is the justification or explanation why at a joint, if there are only two forces, means only two truss members are meeting at that joint and there is no external force and they are not in a straight line, means they are not collinear, then both of them will be equal to 0. I hope you understand this point, and this will help you in identifying these type of questions. And you will find that in most of the competitive exams you will get this type of questions. Your GATE exam or PE exams, this type of questions are asked in multiple choice questions. Now we go to the second. The second rule says if there are only three members at the joint. So this is for three members, and here also these two conditions are same, no external force. So there is no external force acting, only the members are there. So the force is in the members only, and there is no support reaction. So these conditions 1 and 2 are same as the previous condition also for joint with two members and joint with. Now here the third condition says that two of the forces out of three, two of the forces should be collinear. How it will be? Like if we say, okay, there is a joint here and this joint has one force F1, one force F2 and there is a member connected here, F3. So these are only the truss members. There is no other external force applied at that joint. So how? Okay, let us say that this angle is theta. F1 and F2 are collinear. That means they are in a straight line. Okay. Now we do the same thing. We resolve this force F3 into two components. So you will get F3 sine theta here in y direction, and here in x direction you will get F3 cosine theta. And if you apply the same equilibrium condition, that sigma Fy equal to 0, this will give you that F3 sine theta equal to 0, which implies that F3 is equal to 0 because sine theta is not 0. Then when we come to this x direction, now in x direction you have these two forces F1 and F2. So F3 has become 0. Now you have only two forces, and that is your sigma Fx equal to 0. So in that case you can say that F1 plus F2 will be equal to 0. Okay, now we take this example and we apply these two rules to check for zero force members in this given truss here. So first of all, look at joint A. Now at joint A you can see that there are two members. This is A, this point B, and here is E. So we have AB and AE at joint A. And if you look at joint A, there is no external force, there is no support reaction. So if you apply rule number 1, these two forces will be equal to 0. So we can say AB is 0 and AE also 0. Now we come to joint. At B we have these two forces only now, BC and BE. Then if you apply the first rule, we find that these are the only two forces, no support reaction, no external force, so BC will be 0, BE will be 0. So we find that BC and BE equal to 0. Now what is remaining? Look at joint C. Okay, joint C has two forces, but if you look here, there is a reaction from this roller support, and similarly at D there is horizontal and vertical reaction. So we cannot apply it at joint C and D. So now we found that there are four members which have zero force in this given truss. So very quickly we have found out these four forces which are 0. We come to the second example, and in this second example, if you see, okay, at joint A what is happening? At joint A we have these two members, but there is a force also. So we cannot say that the force in member AB and AC will be 0. They will have some force, right? Now we come to joint B. What is happening at joint B? Joint B has 2 plus 1, 3. This is joint B. Here we have D. This is BA. If you look at B, this BD and BA are collinear and BC is the third force. So to maintain the equilibrium, applying rule number 2, this BC will be equal to 0. So we say, okay, BC is 0. Now we come to joint C, and at joint C you can easily see these forces here. This is C, this is A, this is E, and then we have this CD because CB is 0. Now again we can apply the same rule that there are three forces, two of them are collinear, therefore the third force, which is CD, will be 0. So CD becomes 0. And you can say that CA and CE will be equal and opposite. Similarly, BA and BD will be equal and opposite. Now we go to joint D. Okay, now see what is happening at joint D. Joint D has also now three forces. This is D, this is B, this is F, and this force is DE. Okay. Now the same rule number 2 can be applied here because FD and DB are in the same straight line and DE is the third force. So to maintain the equilibrium, applying rule number 2, DE will be 0. Okay. Now, and similarly you can say that DB and FD will have equal and opposite forces. Now we come to joint E. Okay, what is happening at E? Again we find that because ED is 0, so only three forces are now remaining at joint E. So we can say that joint E is having these three forces. This is E, this is C, this is G, and this is F. We apply the same rule that there are three forces, two in the same straight line, therefore apply rule number 2. Third force will be 0, there is no external force, no support reaction. So we get this EF also equal to 0. Okay, now let us check what are the other situations. If we see here at G, because there is roller support, so there will be one reaction here in the horizontal direction because the reaction at the roller support will be always perpendicular to the surface on which rollers are kept. Okay, so it will be in the horizontal direction, and F is a hinge support, so it will have one horizontal and one vertical reaction. Now look at G. The joint G has how many? Two members, right? And there is one reaction. So in that case you can say that there are three forces. Okay, like this, and this force will be equal to 0. So EF G here, so this is G. Okay, and this is F. So this force will also be 0, right? So this way we have identified the 0 force members in this truss. Okay, now we'll go to some other questions here. I have another 2 examples, so we will learn in a better way by solving these 2-3 questions more. If you see in this third one, again we should see where are the support reactions. Joint E is kept on rollers, so there will be one reaction. A has hinge support, so there will be 2 reactions. Now we look at the joints which have 2 or 3. Okay, joint E has how many? 2 members, but there is one external reaction, so there will be no chance of 0 force in these 2 members. We come to joint D. Okay, joint D has this member DF here, and here we can identify easily that okay, here is DE, this is DC, so therefore FD will be equal to 0 because DE and CD are in a straight line, so FD will be 0. Once FD is 0, Now we move on to joint F. Okay, at joint F we have on this side point E, and here is G, and this is your force CF. So we apply the same rule that at joint F there are three forces only, no external force, no reaction. So when we look at these, EF and FG are in a straight line. Therefore the third force CF will be equal to 0. Right? Once CF is 0, we can say that okay, EF and FG will be equal and opposite. Similarly, DE and CD will be equal and opposite. And if we go to joint G, okay, there are four forces. This cannot be applied. Similarly, at joint, now if you see, joint C has three forces, but these are two of them are not in a straight line. Similarly, B has how many? B has 1, 2, 3, 4. Okay, so we cannot say anything about the forces at B, G and A. So now you have seen that very quickly we have found these unknown forces, and we also notice that some of them will be equal and opposite. So your calculation of reactions, which you will be calculating by either method of joints or method of sections, you will get the results very fast. In our next lecture, we will be explaining how to calculate the forces in the truss member by method of joints. Okay, now we go to the next question, and here we have another truss, and there is one roller support here and hinge support here. So hinge will have two reactions, roller one reaction. Now we can easily identify some joints like D is having only two forces and there is no external force, no reaction. So this is D, this is E. So to maintain the equilibrium, both CD and CE will be 0. Similarly, if we look at joint B also is similar to D. So B, and here is C, this is A. So to maintain, rule number 1 will give you these two forces equal to 0. So we have got BC and BA equal to 0. Now we'll see if there is any other joint where we can apply this rule number 1 or 2. Okay, at E now we have only two members, but there is a reaction here. Okay, if we come to joint number F, joint F has three members, but there is one external force. So here it is very easy for you that you can say that the force Fj will be equal to 6 kilonewton when we apply the equilibrium, but that Fj will not be equal to 0, right? It will be equal to 6 kilonewton force. This is another very simple observation and justification to calculate the force, right? So we can quickly say that force Fj will be equal to 10, like this, and these EF and Fg will be equal and opposite. Now we come to joint, yes, joint H. Okay, joint H gives you these three forces. H, this is G, this is A, and this is I. So we apply the same rule based on rule number 2. You can see here GH and AH are in a straight line. Therefore, the third force will be 0. So we got this HI equal to 0. Okay, now we also notice that the joint I has, okay, this force only, because IH has become 0. So we have IG, this is C, this is A. So we find that IC and AI are in a straight line. Therefore, the third force IG will be equal to 0. So we have got this force also equal to 0. Now, how many forces we have got as 0? 1, 2, 3, 4, 5, 6. So very quickly we have got 6 forces equal to 0. So this will reduce your time for calculation of the forces in the truss members, and this is an easy way to calculate the forces in the truss member just by applying those rule number 1 and rule number 2. Now we come to one more question. Here also you can see very easily that support G will give you one support reaction because it is roller, and A is hinge, so it will give you two reactions. So we identify the reactions, in which direction the reactions will be acting. At hinge support, two reactions, roller support will be one reaction. Now look at the joints which can give you these zero force member. So rule number 1, if we look at G and A, at G there are two members but there is a reaction, right? So we cannot apply that rule number 1. Okay, similarly rule number 3 cannot be applied at G. Two forces are not in a straight line. Okay, so we come to joint F. Okay, draw the figure for joint F. So F has G here and E here, and there is H. So when we apply rule number 2, FH will be equal to 0. Once we get FH equal to 0, we can go to joint H. Now look at joint H. Is there any possibility of zero force? No. At joint H there are 1, 2, 3, 4 forces. So we cannot say anything about joint H. Zero force? No. Okay. Similarly at I there are 4 forces. We cannot go to I. Okay. We can come to joint D. Okay. Look at joint D. So joint D has DE and CD. Okay, so we can apply this rule number 2, that this DJ will be 0. Okay, so we have got the zero force in this member DJ. Okay, now can we go to some other? Just look at, okay, M has 1, 2, 3, 4 forces. B and K, we notice that B and K have only 3. Okay, let us come to joint B. So joint B has this one, this is B, this is C, and this is A, this is L. So apply the same rule. BA and BC are collinear, therefore the third force BL will be equal to 0. Okay, now we go to joint K. Okay, look at joint K, and there is a force here. This is K and this is M, this is J, this is L. So KL and KJ are in a straight line, therefore the third force KM will be equal to 0. Now Km has become 0. Once Km has become 0, now look at joint M. Now only 3 forces are remaining. So Km does not exist because there is no effect of the force Km. So we look at joint M. Joint M is having this force. So ML. Now look at this. So there is Mj here, Mc here. So to maintain the equilibrium, because Mj and Mc are collinear, therefore the third Ml will be equal to 0. So we got this force also equal to 0. Now, is there any other possibility? Okay. At L there are 1, 2, 3 members, but there is one external force. So we cannot say anything about the members here. Okay, so with this we come to the end of this lecture. I hope you have learned how to identify the forces which are zero in the truss members. And if you still have some doubt, you can ask some questions in the comments. We will reply to your questions. So if this lecture has helped you in learning better for calculation of truss members, please like and share it with your friends so that they can also get the benefit. And please don't forget to subscribe to our channel. The subscription is completely free. Thank you very much.